Hi, today we will present Lab 4 3-phase synchronous generator. Our group member is Muhammad Hanif Rosdi, matric number B0818100060. Next, Muhammad Naim bin Badrul Hisham, matric number B0818100181. Next, Muhammad Shahrul bin Maadis, matric number B0818100046. Okay, the objective. The synchronous generator or alternator is an electrical machine that converts the mechanical power from a primary mover into an AC electrical power at particular voltage and frequency. The synchronous motor always runs at a constant speed called synchronous speed. Working principle of synchronous generator. The synchronous generator works on the principle of Faraday's law of electromagnetic induction. The electromagnetic induction states the electromotive force induced in the armature coil if it is rotating in the uniform magnetic field. The EMF will also be generated if the field rotates and the conductor becomes stationary. Thus, the relative motion between the conductor and the field induces the EMF in the conductor. The wave shape of the induced voltage always a sinusoidal curve. Okay, this is the procedure. First, install the equipment required in the EMF workstation. Mechanical couple the prime mover dynamometer module to the synchronous motor or generator. Second, on the power supply, make sure the main power switch is set to the O position and the voltage control knob is temporarily counterclockwise. Ensure the power supply is connected to a 3-phase power source. 3. Ensure that the data acquisition module is connected to a USB port of the computer. 4. Start the data acquisition software LVDAT or LVDAM. Open Setup Configuration file. In the metering window, select Layout 2. Make sure that the continuous refresh mode is selected. 5. Connect the equipment as shown in figure 6.2. On the synchronous motor or generator, set the exciter switch to the I-close position and the exciter knob to 3/4 of maximum. 6. Set the 4th quadrant dynamometer or power supply of the prime mover or dynamometer to operate as a clockwise prime mover. To do this, refer to exercise 1.1 or exercise 1.2 necessary. Synchronous generator no load operation. 7. Turn the power supply on set the prime mover speed so that is equal to the nominal speed of the synchronous motor or generator. In the oscilloscope window, select the display continuous reflex function. Slowly adjust the prime mover speed until it is approximately equal to 1000 rpm. While doing this, observe the waveform of the voltage on channel E1, E2, and E3 in the oscilloscope window. Okay, now for the question. How do the amplitude and frequency of the voltage waveform vary when the speed of the synchronous generator is decreased? Explain why. Okay, the answer is the waveform varies if the frequency and amplitude in wave voltage is decreased when the speed synchronous generator decrease. Next, does rising the speed of the synchronous generator affect the phase shift between the voltage waveform? Why? Okay, the answer is it not affect because phase shift not determined with speed in the voltage waveform term. Okay, next. On the synchronous motor or generator, slowly turn the exciter knob counterclockwise to decrease the field current. While doing this, observe the waveform voltage on channel E1, E2, and E3 of the oscilloscope. The question is, how does the amplitude of the voltage waveform vary when the field current IF of the synchronous generator is decreased? Explain why. Okay, the answer is the three-phase synchronous generator will produce the amplitude of the voltage waveform when the synchronous generator increase, then the field current IF decrease. The voltage of synchronous generator will increase to compensate because the decreased value in current, so it will also change the value in amplitude of voltage waveform in increase. Next question. Does varying the field current IF of the synchronous generator affect the frequency of the voltage waveform and the phase shift between the voltage waveform? Why? Okay, the answer is the main term to determine the varying value in field current of synchronous generator and the phase shift is the wheel of generator itself. Okay, this is oscilloscope waveform that we get. Okay, conclusion. In this exercise, you observe that a three-phase synchronous generator produces three sine waves, voltage that are phase shift by 120 from each other. You saw that decreasing the synchronous generator speed decrease the amplitude and frequency of the sine wave voltage. You observe that decreasing the field current of the synchronous generator decrease the amplitude of the sine wave voltage. You plotted a graph of the synchronous generator output voltage versus the field current. You plot graph of the synchronous generator output voltage and frequency versus speed. This graph shows that the output voltage and frequency are proportional to the synchronous generator speed. Review question. Number 1. Most electrical power that is consumed today is produced by? The answer is D. B and C. B is synchronous generators and C alternators. Second, when the speed of a synchronous generator is increased, the answer is D. Both the output voltage and frequency increase. Third, how does the field current affect the frequency of the voltage produced by a three-phase synchronous generator? The answer is C. Frequency is not affected by change in field current. Fourth, multiplying the speed of an alternator by P16 allows the answer is A. Theoretical frequency to be determined. Okay, last, number 5. Alternator is another name for? The answer is B. Three-phase synchronous generator. Thank you.